So we are getting into the ECS section, but before talking about ECS, we need to talk about Docker. So Docker is something you may have heard before. I'll try to simplify it. You can make a 12-hour long course on Docker, but I'll try to make it short in 4 minutes. So what is Docker? Docker is a software development platform to deploy apps. So the way we've been deploying applications from before is to install them on Linux and then they will work. But with Docker, you will package your app into something called a container, and that container is very special because it can be run on any operating system very easily. The app, once in a container, will run the exact same way regardless of where they run. So it could be any machine, no compatibility issues, with predictable behavior, less work, easier to maintain and deploy. It will work with any programming language, any operating system, any technology. And with Docker, you can scale containers up and down very quickly in a matter of seconds. So that makes Docker something that is extremely powerful nowadays to deploy applications. So if we talk about Docker on an EC2 instance, we would have, for example, a Docker running Java code, a Docker running Node.js code, a Docker running a MySQL database, a Docker running Java, and so on, all onto the same EC2 instance. So the idea is that if we manage to package our application in a Docker container, then it will become very easy for us to run it on an EC2 instance. So Docker images, you need to create them. This is how your container will be run, and they can be stored in something called Docker repositories. So there is a public Docker repository called the Docker Hub, available at this address, and you can find the base images for many technologies or operating systems. So for Ubuntu, which is a Linux operating system, or MySQL, this is a database technology, Node.js, Java programming languages, or as we'll see in this section, we can use Amazon ECR, which is a private Docker repository. So this is where you can store your private Docker images. So this is more advanced, but the question is, do you want to use Docker or a virtual machine? So Docker is sort of a virtualization technology, but not exactly. So the resources are shared with the host. That means that you can have many containers on one server. So if we look at comparing EC2 and Docker, this is how it works. So we have the infrastructure, which is on AWS, the host operating system, then the hypervisor, and this is stuff we don't have access to. And then finally, when we get an EC2 instance, we have our application onto the guest operating system. And so if we want another EC2 instance, it will be created like this, and a third EC2 instance, it will be created like that. So this works great, and this is what happens when we create EC2 instances. But in the case of Docker, we have the infrastructure, the host OS, which is the EC2 instance, and then the Docker daemon. And then as soon as the Docker daemon is running, we can have many containers running onto the Docker daemon, and they're more lightweight. They don't come with a full operating system and a virtual machine, all of them. And so that makes Docker very versatile, very easy to scale, and very easy to run. So this is just an overview of Docker. You don't need to know what Docker is going into the exam, but I wanted to give you that sweet little overview in case you were curious. And in the next lecture, we'll deal about how to do Docker on AWS, and that will be ECS. So I will see you in the next lecture. So now let's talk about ECS. ECS stands for Elastic Container Service, and this is used to launch the Docker containers we just talked about on AWS. For it to work, we need the Docker containers to run somewhere, and so for ECS, you must provision and maintain the infrastructure yourself, so that means you need to create EC2 instances in advance. AWS will take care of starting or stopping the containers for you, and it has integration with an application load balancer if you wanted to create a web application on ECS. So as a diagram, we would have multiple EC2 instances, and we would need to create these EC2 instances in advance, and they will be running different containers by the ECS service. Now the ECS service, anytime it has a new Docker container, it will be smart enough to find on which EC2 instance to place that Docker container. So anytime in the exam you see, I want to run Docker containers on AWS, think of ECS. Now let's talk about Fargate. So Fargate is also used to launch Docker containers on AWS. But this time with Fargate, we don't need to provision any infrastructure. So we don't need to create any EC2 instances and manage them. And this is a much more simple offering from AWS. This is actually a serverless offering because we don't manage any servers. AWS will just run the containers that we need based on the specification of CPU and RAM for each container. So Fargate is going to be a lot simpler to use, and I like it personally a lot. So Fargate is here. Say we need to have a new Docker container to be run on Fargate. Then Fargate will automatically run that container for us. We don't exactly know where, but it will be run. And so the idea here is that with Fargate, we don't manage any EC2 instances, and so it is easier to use. So before with ECS, we first created our EC2 instances, but with Fargate, we don't. But both services allow you to run Docker container on AWS. Finally, for storing these Docker images so that they can be run on AWS, you need to use a container registry. And for this, we can use ECR, which stands for Elastic Container Registry. It is a private Docker registry on AWS, and this is where you're going to store your Docker images so that it can be run by the ECS service or the Fargate service. So to take an example, we have ECR and Fargate. We're going to store our images of our application onto Amazon ECR, and then Fargate will be able to look at these images and create a container from them and run them directly on the Fargate service. So it could be one container here, one container there, but this is ECR, so we could have multiple images as well, creating different containers on Fargate. So that's it. Very, very simple. So remember, ECS versus Fargate versus ECR, that's all you need to know going into the exam. I hope you liked it, and I will see you in the next lecture. So now I want to formally introduce the serverless section to you. So what is serverless? Serverless is a catchy word, but it is a new paradigm in which the developers don't manage the servers anymore. They just do what they do best. They just deploy the code, or they deploy functions. So initially, serverless was pioneered as a function as a service with AWS Lambda, and that means that you just deploy your code and each function will be run independently by the Lambda service. But nowadays, anything that's serverless is mostly mentioned as something that is managed, and that doesn't include servers managed by the user. So that includes serverless databases, messaging, storage, etc. So serverless does not mean that there are no servers. There are, of course, servers behind the scenes, otherwise services would not work. But it just means that as an end user, you don't manage, provision, or even see the servers. So in this course, we have been using some serverless services from the beginning. So Amazon S3 was one of them because we used it as a storage layer, but we didn't manage any servers at all, okay? Amazon S3 can scale infinitely. There was no servers, we just uploaded file, and that was it. DynamoDB was another one. So in DynamoDB, we just went ahead, we created a table, but we didn't provision a server for that table, and that table could autoscale based on the load it was receiving. So that makes it another serverless service. Fargate is another one. So Fargate was to run Docker containers. And as I said, with ECS, you create EC2 instances to run the Docker containers. So that would not be serverless. But with Fargate, you just send the Docker containers and Fargate will automatically find a way for it to be run. So that makes it another serverless service. And in this section, we're going to see Lambda, which was the pioneer of serverless services. So Lambda allows you to run functions in the cloud. So this is it for the quick intro to serverless. I will see you in the next lecture to talk about Lambda. Okay, so now let's talk about AWS Lambda. So if we use an EC2 instance, we have a virtual server in the cloud, but we are bounded by the amount of memory and CPU power we give it. It is continuously running, even though sometimes we don't use it. And if we want to scale, we can use an auto-scaling group, but that means that we need to add or remove servers over time. That may be a little slow, or that may be sometimes very complicated to implement. With Lambda, this is a new way to think about it. In this case, we don't have servers, we just have virtual functions. And these functions are limited by time, so they're intended for shorter type of executions. They will run on demand, so that means that whenever we run a function, it will be there to be run, but whenever we don't need a function, it will not be run and we will not be billed for it. And in case we need scaling, it's already automated as part of the Lambda service, and this is why Lambda is a very popular service from AWS. So the benefits of using AWS Lambda is that the pricing is, first of all, super easy. You're going to pay per request and per compute time. And the free tier is also very generous. So you get every month 1 million Lambda invocations and 400,000 gigabyte seconds of compute time, What this means is that you can run on Lambda some pretty good services for free. Now, it is integrated with the whole AWS suite of services, so we have integration with so many of the services we've seen so far, and it is, very important, event-driven. So the functions will only get invoked by AWS when something happens, when an event happens, or when needed. So that makes Lambda a reactive type of service, which is important going into the exam. It is fully integrated with many programming languages. You get easy monitoring through CloudWatch. We haven't seen what CloudWatch is, but it will be the monitoring solution in AWS. And finally, it's easy to get more resources per function. We can get up to 10 gigabytes of RAM per function. And if you do increase the RAM, it will also improve the CPU and the network quality. So all in all, very good. Lambda can run many languages. It can run JavaScript through Node.js, Python, Java, C#, Golang, C#, PowerShell, Ruby, and any language you want through the custom runtime API. And one last runtime is called the Lambda container image. And this allows you to run actual Docker containers on top of Lambda. But these container images must implement the Lambda runtime API, which is not the case for every single Docker image. So they are very, very specific Docker images that you can run on Lambda. And so coming to from an exam perspective, you don't need to remember all the languages up there, but still it's good for you to have a list. But if it comes to running Docker images on AWS, ECS and Fargate is going to be a preferred way of running these arbitrary Docker images, so any kind of Docker images. But the Lambda container image does exist if the Docker image is compliant with the Lambda runtime API. That may be too specific for the exam, but I wanted to let you know of this detail. Here is a very common use case of Lambda, which is to create a serverless thumbnail creation service. So say we have an S3 bucket and we add images in it. So our users are uploading a beach image into an S3 bucket. The S3 bucket will trigger a Lambda function once the image is uploaded, and that Lambda function will take that image and will change it to create a thumbnail. It will push the thumbnail back into Amazon S3, so a thumbnail is a smaller version of the image, or it will also push some metadata about the thumbnail into DynamoDB. That includes the image size, the image name, the creation dates, etc., etc. And all of this is fully event-driven and fully serverless. With S3, we don't provision servers. With Lambda, we don't provision servers. And with DynamoDB as well, we don't provision any servers. So that is a great pattern because this serverless thumbnail creation will scale really, really well, and we will be able to not worry about provisioning servers to make it scale. Now, there's another very common use case for Lambda, which is to create a serverless cron job. So cron allows you to define a schedule, for example, every hour, every day, or every Monday, and based on that schedule, to run a script. And by default, a cron job is run on a Linux AMI, so on a Linux machine. But we are serverless, so we cannot provision an EC2 instance. So instead, we'll be using something called CloudWatch Events or Event Bridge. And this service that we'll see later on in this course will be triggering every 1 hour our Lambda function to perform a task. And effectively, we have no servers in this because CloudWatch Events is serverless and Lambda is serverless. And so effectively, we're launching a script every hour through a Lambda function. So I hope you can see now the trigger of it. The Lambda functions is really for serverless functions in the cloud. Now let's just talk about the pricing. So you can find the Lambda pricing at this URL, but it's very simple. You pay per call, so that means the first 1 million Lambda invocations are free. And then it's also very, very cheap. You're going to pay 20 cents per 1 million requests thereafter. You're also going to pay for the duration. So the free tier, as I said, is 400,000 gigabyte seconds of compute time for free. And that means it's 400,000 seconds if the function has 1 gigabyte of RAM, or 3.2 million seconds if the function has 128 megabyte of RAM. After that, you're going to pay $1 for 600,000 gigabyte seconds. So all in all, the bottom line is that it's going to be very cheap to run Lambda on AWS. And so it's a very popular service to run your serverless applications and websites. And going into the CCP exam, you need to remember that Lambda pricing is based on calls and duration. So that's it for this lecture. I hope you liked it, and I will see you in the next lecture. Okay, so we're going to practice using the Lambda service. And when you go in Lambda, you may end up on this screen, but there's another screen I really like. And so if you're in your URL, you replace /discover by /begin, you may end up on this screen, which I really like because it has an educational value I want to show you. So Lambda is here to help you run code without thinking about servers, and this makes it a truly serverless service. So the idea is that we can use any type of programming language we want, for example, .NET Core, Go, Java, Node.js, Python, Ruby, or any custom runtime if you want to have a runtime provided by an open source project. For example, the Lambda Rust runtime is possible. And so from this code, you will have it written, uploaded into the Lambda console, and then AWS Lambda will run the code for you. So let's take a very simple code. For example, Python with a Lambda handler is going to print the event and then say return hello from Lambda. So let's click on run and we get hello from Lambda. So that means that the Lambda function just ran the code that we have provided right here. Very simple, right? Next, how do Lambda functions get invoked? So we can click on the run button, obviously, but also we can have Lambda respond to events. And this is what I want to show you. I think it's really cool. So as we can see, events can come from various sources. For example, in this one, this is streaming analytics. And so as the streaming analytics is sending events into a Lambda function, the Lambda function is returning hello from Lambda, hello from Lambda, hello from Lambda, and so on. But it's not just the streaming analytics. If you click on the phone right here, it's going to send a message into a mobile IoT backend. And this IoT backend will also invoke our Lambda function. Same for if we take a photo and upload it into an S3 bucket for data processing, then the Lambda function will be invoked. But the cool thing is that if you start clicking a lot on one of these sources, you can see on the right-hand side, we have more cogwheels. So as the left-hand side flow and invocations of Lambda scales, then the number of Lambda invocations and concurrent Lambda functions running will be scaling as well. So it's really cool because that means that as we have more load, automatically Lambda will scale with our load. And that is a whole power of using Lambda as a compute platform. And this is why Lambda is serverless and it scales really well. So if we go in here, as we can see, as the Lambda function is invoked, we get more invocations over time. And the cost remains 0 because there's a free tier. And as soon as we will pass 1 million invocations, then the Lambda function will start incurring some charges. So if we go in there and start having over 1 million invocations, here we go. Now we're getting some sense. As you can see, we are at almost 2 million invocations and we have only 14 cents as a cost. So it's very, very, very cost efficient to have a Lambda function and to run some workload at scale. So as you can see, you can play around and seeing that the more you have invocations, the more the cost goes, but it's really, really controlled. And Lambda can be quite a cost saving mechanism if you use it at scale. So this is just for the introduction to Lambda. Now, if I click on create a function, we are offered with 4 options to create a function. And for this example, we're going to use a blueprint. And in the blueprint, just type in hello, and we'll use the hello world Python blueprint. So you click on it, and we'll deploy this blueprint. So configure it. The function name is just demo Lambda, because this is just our hello world for this course. We'll create a new role with basic Lambda permission. So we'll leave it as the default option. And then here is the code that will be imported into our function. So this is going to be a Lambda handler that will print 3 values into the log and then return 1 value. So let's click on create function. And now this function is being created. And in the second, we'll be able to run it. Okay, so my function is created. And as we can see, the code has the code source in here. And if I click on lambda function.py and open it, we can see that the function code we had from before is now loaded into this code editor. So why don't we go ahead and test this function? So I'm going to click on test, and we need to create a new test event, which is a hello world event, which contains key 1, value 1, key 2, value 2, key 3, value 3 as a JSON document. So I'll call this one demo event and click on create. So now the demo event was successfully saved. So if I click on test now, it was going to run the demo event, and the response is value 1. The function log is that value 1 equals value 1, value 2 equals value 2, value 3 equals value 3, which is just a result of this 3 print statements. And finally, the response value is value 1, again, due to this line of code. So it may not look like much, but from a programmer's perspective, as you can see, you had just some code and it was uploaded into Lambda, and then it was run by Lambda very quickly. So this is a huge improvement if you're a developer. As you can see, to deploy the code and have it run. But on top of it, it runs seamlessly and it will scale automatically and it is fully serverless. Okay, we didn't deploy any servers. Now, in terms of build duration, so if you go in here and scroll down, then as you can see, the duration was 2.32 millisecond. We've been billed for 3 milliseconds of execution. And here's the memory size that we've provisioned and the one that was used and how much the init was, because this is the first time that we use our Lambda function. Now, if I run it again, if I go back to my function, and run this one again, as we can see now, the function duration was 1.33 millisecond. And on the right-hand side, there was no initiation because my Lambda function was ready to be used. Okay, so that's one way of doing things. Now, the other thing I want to show you is that from this Lambda function, we're able to configure it. So if I go into general configuration, we get some of the most important settings. The first one is around memory. So we can have the memory from anywhere between 128 megabytes up to 10,240 megabytes of memory. Obviously, if you have more memory, you're going to get billed more. In terms of timeouts, we can go anywhere between 3 seconds or 5 seconds all the way to, as you can see, 15 minutes. So the maximum timeout is 15 minutes, but you want to make sure that you only use the function for the time that you think is going to be used for. And then the execution role is the one that was created by Lambda in the beginning. Okay, so those are some of the most important settings, okay? And the other thing we can look at is monitoring. So in monitoring, we're able to see what is going on with the Lambda function. So how many times it was invoked. So here 1 time, how long it lasted, whether or not there was errors or successes, and so on. So it could be quite helpful, but we have integration with CloudWatch metrics and also CloudWatch logs. So right now we have nothing, but we could look at the CloudWatch logs right now when the function runs. So to do so, just refresh on the right-hand side the recent invocations, and we can see that there's a log stream right here. So if I click on it, I am taken directly into the CloudWatch logs, and we can see that on the CloudWatch logs, we have all the logs of the invocation of this Lambda function. And this is within a log group called AWS Lambda, Demo Lambda, and Demo Lambda is the name of my Lambda function within my region, obviously. And we have one log stream right here. So we get all the logs into Lambdas. And other things you can try is to modify the code. For example, if we take this code, we go to the Lambda function, and I will comment this line of code by adding a hashtag and uncomment this one. This is going to raise an exception. So to do so, I need to first deploy the changes by clicking on deploy. Now the changes have been deployed, and now I can test my function. And in this type, we get a execution result, which is an error, where something went wrong. Type is exception, as we can see, something went wrong, which was triggered by this code, line of code right here. So any type of errors also will be reported by Lambda, and you could look into CloudWatch logs to understand as well where the log of the error happens. So if I go back into CloudWatch logs, there's a second log stream right here, which I'm going to open, and we get this exception right here. So it's possible for us to go back as well to the logs of the exception within CloudWatch logs to understand the root cause of the issue. So fairly easy. Now, if you want to make the function run again, fine. You just reverse what you did and you click on test. And again, now this time, this Lambda execution function will work. So some of the last things we may want to check out is the fact that in here, the runtime settings, we're running Python 3.7 in this example, but you may get an updated version maybe on your end. And the handler is lambda function.lambda handler, which is saying to look at the lambda function.py file and the function name lambda handler. So if we go up, we can see the function name is the lambda underscore function.py. And within it, we have the lambda underscore handler function. So this is why it knew to invoke this function particularly. Also, we have written to CloudWatch logs, and the reason we were able to do so is that if we go into the configuration of our Lambda and go to the permissions tabs, we have a role name called demo Lambda role that was created for us by the Lambda console. And if you look at the policy itself, we can see within the policy summary that we have access to write to CloudWatch logs, which is something you can also see right here by resource summary, that CloudWatch log has 3 actions on 2 resources, which allow us to create log stream and log groups and also send the logs to CloudWatch logs. So this is the whole idea behind this permissions tabs right here. So that's it for this lecture. I hope you liked it. And if you are in the Certified Developer course on AWS, then get ready for an extra few hours of content on Lambda. And if you're not, well, this is enough for your exam. I hope you liked it, and I will see you in the next lecture. Now let's talk about a quick service called the Amazon API Gateway. So this comes from the use case from an exam perspective of you wanting to build a serverless HTTP API. So in this example, we have serverless technology. So we're using Lambda, and we're reading, creating, updating, and deleting data from DynamoDB, which are both serverless technologies. But we want external clients to be able to access our Lambda function. But a Lambda function is not exposed as an API right away. For this, we need to expose it through an API gateway, which is going to provide the client with the REST HTTP API to connect directly to your website. And so, as you can see, the client will talk to the API gateway. The API gateway will proxy the request to your Lambda functions, which will execute the transformations on your data. And so API gateway is used as a fully managed service that is going to allow developers to easily create, publish, maintain, monitor, and secure APIs in the cloud. It is a serverless technology, and it is fully scalable. It supports RESTful APIs and also WebSocket APIs for real-time streaming of data. It supports also security, user authentication, API throttling, API keys, monitoring, and so on. So when you see going to exam a way to create a serverless API, you need to think about API gateway and Lambda. That's it for this lecture. I hope you liked it, and I will see you in the next lecture. So now let's talk about a service that is named after what it does. It is AWS Batch. So Batch is a fully managed batch processing service that can allow you to do batch processing at any scale. And with the batch service, you can efficiently run hundreds of thousands of computing batch jobs on AWS very easily. So what is a batch job? Well, a batch job is a job that has a start and an end. And that is opposed to, say, a continuous or a streaming job that really doesn't ever end. It's always running. But a batch job, say for example, starts at 1 a.m. and finishes at 3 a.m. So a batch job has a point of time when it happens, and so the batch service will dynamically launch EC2 instances or Spot instances to accommodate with the load that you have to run these batch jobs. So batch will provision the right amount of compute and memory for you to deal with your batch queue. And you just submit or schedule batch jobs into that batch queue, and the batch service does the rest. Now, how do you define a batch job? Well, it is simply a Docker image and a task definition that you run on the ECS service. So this is pretty much saying that anything that can run on ECS can run on batch. And this is going to be very helpful to use batch to run these batch jobs, and because it automatically scales the right number of EC2 instances or Spot instances to do these jobs, then you get lots of cost optimizations and you focus a lot less on the infrastructure, you just focus on your batch jobs. So this should be more than enough for going to the exam, but I just want to show you a small diagram that I made. So for example, say we wanted to process images submitted by users into Amazon S3 in a batch way. So an image will be put into Amazon S3, and this would trigger a batch job. And so batch would automatically have an ECS cluster made of EC2 instances or Spot instances, and batch would make sure that you have the right amount of instances to accommodate with the load of batch jobs you have in the batch queue. And then these instances will be running your Docker images that will be doing your job, and then maybe that job will be to insert the processed object, maybe it's a filter on top of the image, into another Amazon S3 bucket. So the question you may have is, what is the difference between batch and Lambda, because they look similar? So Lambda has a time limit, it's 15 minutes, and you only get access to a few programming languages. On top of it, you have limited temporary disk space if you want to run your jobs, and it's going to be serverless. Whereas batch is very different. So batch has no time limit because it relies on EC2 instances. It's any runtime that you want as long as you package it as a Docker image. And for storage, you rely on the storage that comes with an EC2 instance. So it could be an EBS volume or an EC2 instance store for disk space, which can be a lot more than for Lambda functions. And then finally, batch is not a serverless service, it's a managed service, but it relies on actual EC2 instances being created. But these EC2 instances are managed by AWS, so we don't need to worry about the auto-scaling and so on. So I hope that was helpful, and I will see you in the next lecture. Amazon Lightsail is a bit of an oddball in AWS because it is kind of a standalone service. So with Lightsail, you can get virtual servers, storage, databases, and networking in one place. It gives you low and predictable pricing. And so the reason people use Amazon Lightsail is that it is a much simpler alternative to using services that we've been learning, such as EC2, RDS, ELB, EBS, Route 53, and so on. So Lightsail, really the intent of it from AWS is for people that have little cloud experience and don't want to learn how the services work intricately. For example, how the networking works, how the storage works, the server works, etc., etc. This is not something you would use. You're learning how AWS works properly. But if you're someone with little to no cloud experience, then Lightsail may be a service for you. From Lightsail, you can also set up some monitoring and notifications for your Lightsail resources. And so use cases for Lightsail will be, for example, if you want to deploy a very simple web application. For example, if you have a LAMP stack, Nginx, Mean, Node.js, there's templates for that on Lightsail. Or if you have a very simple website, for example, if you have a WordPress, a Magento, Plesk, Joomla, all these kind of things can be deployed very easily on Lightsail. Finally, Lightsail is also great if you have development and test environments in AWS. There is a concept of high availability in Lightsail, but there is no auto-scaling, and there really are limited AWS integrations. So to summarize, Lightsail really is something that you wouldn't use today on your own, but from an exam perspective, if you see someone that has no cloud experience and need to get started quickly with a low and predictable pricing without configuring things much, that would be Lightsail. Otherwise, Lightsail will almost always be a wrong answer. So I hope that was helpful, and I will see you in the next lecture. So I want to quickly show you what Lightsail looks like. We're not going to play much with it, but I want to show you what it looks like. So Lightsail, as you can see, looks nothing like AWS. It is a separate service because it doesn't have any kind of good integrations with AWS. So let's get started with Lightsail. Then you need to create an instance, and so say, where is this going to be? And so as you can see, you can change the region and the AZ from here for that instance, and there's limited amount of regions available to you. So for example, we can say, okay, I want one in Ireland. Then, based on where you select your instance to be, you're going to get some parameters to configure your instance, but you're going to get a lot less. So you can pick an instance image, which would correspond to an AMI, but again, all these things are hidden from you in Lightsail. And so, for example, we can say, okay, we want to use a blueprint, such as a template, and we can use the OS only. This would be very similar to EC2, but we can go with app and OS. For example, we can say, okay, I want to launch a WordPress website right now. And you click on this and you have a WordPress website. So as you can see, Lightsail is a much lighter, as the name indicates, and it's really meant for you to be quickly up and going on AWS without understanding the entire infrastructure that goes behind it. So this is for very simple applications. So we can have an optional launch script, which is an EC2 use data. We can change the SSH key pair if you wanted to, but as you can see, all these things are kind of hidden. They don't want you to modify these parameters right away. The cool thing here is the instance plan. So we have a lot less customization here. We don't see the EC2 instance types. We just see some instances with a price indicated. So it's easy to understand the price is going to cost me. For example, this one will cost me 3.5 USD, but the first month is going to be free. So maybe that's the one I want. And we can see how much RAM, CPU I get, and disk space. So this is really, really easy to use. As you can see, we don't have that many instance types possible. We can go all the way to one that costs $160 per month, and we see 32 gigabytes of memory, 8 vCPU, 640 SSD, and 7 terabytes of network transfer. So fairly easy. I'm going to just pick this one because it's in the free tier, and then you have to make sure you delete it at the end. So it's going to be WordPress 1, and I will create this instance. So as we can see here, no security groups, no networking, no EBS volumes. Really, it's meant to be very, very simple, and that's the main idea behind Lightsail. So while this instance is pending, again, we could go ahead and create a database. So you could create a database, and again, this is not RDS, this is Lightsail, so it's going to be much more easy. You choose again the region and the AZ, you pick the database type, and then you can specify some credentials for the login if you want standard database or high availability, and then the price you're willing to pay. And again, this database right here will get you the first month free, but then it would be $15 per month. So as you can see, again, it's a very simplified version of AWS, hence the name Lightsail. We could do the same with networking. I won't show you right now, but you can create all these three things, including a load balancer, in the networking section. We could do storage to get some more storage disk and snapshots for your backup. So this is a very simplified one view of AWS. Now let's look at our WordPress. So here, if I click here, this actually gets me into an SSH terminal into my EC2 instance. So I need to wait a little bit for it to boot up. So if I now try again, I'm able to connect to my instance using a version of SSH through the browser. So again, it's really intended to be very easy to be used. So we're not going to do any commands on the SSH, but as we can see, a WordPress was deployed, and so I can click on it and view it, and then we can connect using SSH again from the same thing. But if we look at the public IP that is running and open this in a new tab, then we're going to connect into our WordPress instance. And so we are getting our Hello World blog, and I'm not a WordPress expert, so I'm not going to show you how to modify this, but the idea is that yes, something is being created on our instance, and that was very, very easy. So Lightsail, I hope you get an idea of what it is. It's meant to be a lightweight version of AWS, but it's not something you're going to use in your job, I believe, as an AWS developer, sysops, cloud practitioner, solutions architect, etc., etc. Still, a good idea to know about the service, and it can come up at the exam, usually as a distractor, very, very rarely as a service you should get the answer of. So that's it. When you're done, please make sure to delete that instance. So you click on delete and then delete the instance so that you don't incur any charges. So that's it. I hope you liked it, and I will see you in the next lecture. Okay, so let's do a summary of all these new compute services we just learned about. And the first thing is that we learned about Docker, which is a technology, a container technology that allows you to run applications. And we've seen how to run Docker on AWS. The first way is to use ECS, and this is going to allow you to run your Docker containers on EC2 instances, but you have to provision these instances in advance. For Fargate, it is the exact same way, but this time we run the Docker containers without provisioning the infrastructure. It is transparent to us, and that makes Fargate a serverless offering because we don't manage any EC2 instances to run these Docker containers. These Docker containers can be stored on AWS using ECR, which is a private Docker images repository. And we've also seen about the batch service. Batch allows you to run batch jobs on AWS across a set of managed EC2 instances. And actually, the batch service actually runs on top of the ECS service. We've finally seen about a new type of service to run predictable and low pricing simple applications and database stacks, which is Lightsail, which is most likely going to be a distractor at the exam, but we've done a hands-on, and now we know what to expect and how this service works. So now let's talk about Lambda. Lambda is going to be a serverless service, which is going to give you a capability of function as a service. And it's going to have seamless scaling, so from one invocation to thousands of invocations per second, and it's fully reactive. You have two components for building of Lambda. You have by the time run times the amount of memory provisions for your Lambda function, and also by the number of times your Lambda function has been invoked. In terms of language support, it supports many different kinds of programming languages. And even though it supports container images, they need to implement a specific runtime API. And so I like to say that Lambda does not support arbitrary Docker images. For this, you would use ECS and Fargate. But if your Docker image does implement the Lambda container runtime API, then you can run Docker images on Lambda. But this is not the standard again. The invocation time is up to 15 minutes. And the use cases for Lambda is to create thumbnails for images uploaded onto Amazon S3, for example, or to run a serverless cron job. Finally, if we wanted to expose our Lambda functions as APIs, we would use another serverless service called the API Gateway that would allow us to expose our functions as HTTP APIs, but also give us capabilities around security, throttling, API keys, and so on. So that's it for this section. I hope you liked it, and I will see you in the next section.